Chapter 7, Experimental Research Strategy. Experimental research is the most powerful research design that we cover in this course. The goal of experimental research is to establish the existence of a cause and effect relationship between two variables. What does it mean? It means that you have two variables, you manipulate or change one variable to see how the change in this variable affects the other variable, assuming that all other variables are controlled. So basically, an experimental research has four basic elements. So if I show you a research article and I ask you, tell me what type of research design is this, you have to look for four elements to be able to say that this is an experimental research. First, manipulation. Manipulation, as I said, means that you change one variable to see how it affects the other variable. For example, you change the amount of light to see how it affects the plant grow. The other element is measurement. If you want to do experimental research, you have to be able to measure your variables. So for example, you change the level of lighting, or you put your plants in 3 levels of lighting, like 2 hours sunshine, 4 hours sunshine, and 8 hours sunshine, and see how it affects the plant growth. The other thing is comparison. Usually in an experimental research, we have two groups of control group and experimental group. Or in this example, you have 3 levels of lighting, so you have 3 groups that you want to compare. And finally, you have control. When you are investigating the effect of one variable on the other one, you want to control all other variables. For example, if you want to compare the effect of lighting on plant growth, so you want to control for the kind of fertilizer that is used in each condition, the kind of soil, the amount of temperature, and the level of oxygen. They all has to be equal, otherwise you cannot be sure that it is the amount of lighting that makes the difference, not the other variables. So in each experimental research, we are dealing with most of the time we're dealing with two types of variable: the independent variable and the dependent variable. The independent variable is the one that we manipulate, like the level of writing is an independent variable. Or if you're comparing teaching methods, the teaching method is the independent variable. Sometimes the independent variable has only 2 levels, like traditional teaching and constructivist teaching. Sometimes it has more than 2 levels, like high light, medium light, and low light. The other variable is the dependent variable. The dependent variable is the outcome or the results of what we experiment. So for instance, in our example, the size of the plant is the dependent variable. Or if you're comparing different teaching methods, student success or student score is going to be your dependent variable. And finally, everything else is an extraneous variable. Any other variable other than the independent and the dependent variable is called extraneous variable. So for example, the level of oxygen, the kind of fertilizer, the temperature, the noise, or in case of students, the age, the IQ, and the gender, they're all extraneous variable that we have to control if we want to do an experimental research. The problem with experimental research, according to uh, critics of experimental research, is that because we control so many variables, we are actually creating an artificial or non-realistic situation. So nobody is going to ask you about the validity of your research, in terms of internal validity or the power of your research, because you're supposed to control. But when you control so many variables, they're going to ask you, so this is not a real life that you can control all those variables. However, something that you need to know is this is not actually a disadvantage. This is an advantage of an experimental research. Uh, I have to give you an example to explain this. You all know that if you drop a feather and a hammer from a top of a four-story building, the feather and hammer don't reach the ground at the same time. While we know, according to the laws of motion in physics, they're supposed to reach the ground at the same time if there is no air. However, since we have air resistance, it happens that the feather is gonna reach the ground later. But if you do the same experiment on the moon, you see that the feather and the hammer reach and that's gonna follow the laws of motion, because we don't have the air resistance, the extraneous variable over there. It's a good thing that we can control to see how variables are related or how variables are affecting each other, and then we can be worried about how realistic is this kind of research.